Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry, Peter Shannon, and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
Is transportation and mobility, which includes air and ground and maritime and everything in between, which is really what we're going to talk about today. And that the future of transportation that we're building right now is how to enable this multi-modal connectivity. So that the key is not just how good is my vehicle or how good is my system, but it's how effectively across cost and time and comfort and emissions and everything can I get a passenger from A to B.
Hey everybody, welcome back to The Vertical Space. First, thank you for your positive comments on our discussions. We're thankful we're able to provide meaningful conversation with great guests on such important topics. Hey, listen, it's a lot of fun for us as well. So today we have yet another terrific guest and another great conversation with Billy Thalheimer, CEO and co-founder of Regent. So we've all been hearing such positive news about Regent. But what makes Regent really so darn attractive? They're not just getting orders, as many are, but they're getting firm orders. And they have also recently made news by bringing aboard two top-end advisors, Dennis Muhlenberg and David Neilman. I'm huge fans of both. And of course, Dennis has been on The Vertical Space. Billy makes it clear that Regent is addressing a multimodal coastal transportation opportunity with a novel vehicle, the Sea Glider. And don't call it an aircraft. But are you really convinced that it's not an aircraft? Listen to the use case, the technology, the range of existing battery technologies, and why. But listen to the challenges that others don't have as well. A terrific conversation around the maritime certification with Coast Guard and other organizations versus the FAA and other aviation regulators. Many are enamored with Regent because they've done an underround, so to speak. They've seemingly minimized some of the more obvious risks that others have in advanced air mobility. FAA certification, landing infrastructure, air traffic control and congestion, range for electric aviation, size of vehicle and its passenger comfort, and so on. With assistance from especially Luka and Peter's questions, listen how Regent has their own set of challenges, which Billy so artfully addresses. This exchange is worth your time. I sat back and savored it. Listen how Billy throws his peers under the bus, as he says, as he expresses skepticism on whether or not some of the current advanced air mobility vehicles will actually hit their projected timelines, given what they said they would accomplish 5 years ago and what they've accomplished since, and the Herculean feats, as Billy says, that some of them have to pull off to meet their objectives. Love the gut punches. I'll be curious to hear your feedback of some of you traditional skeptics of eVTOLs. Do you share the same skepticism with Regent? Or are they so different that you support their approach? Let us know. Billy's a skilled communicator. He clearly understands his market and his vehicle. He boldly expresses his opportunity and is frank, clear, and head-on about his challenges. And like many of our guests, Billy is a thoughtful, smart, visionary, and leader. Listen to his advice to other business leaders and innovators, what he learned from working as an intern with Jeff Bezos at Blue Origin, and how he leads his team today, and what technology he thinks you should be focusing on. Many thanks to Billy for joining us, and to our listeners. Enjoy our talk with Billy Thalheimer as you innovate in the vertical and maritime space.
This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
Billy Thalheimer is the CEO and co-founder of Regent. He is a multidisciplinary aerospace engineer and business development leader. He has led all aspects of the aircraft development process, from business case studies and initial drawings, through detailed design and integration, to flight testing and operations. Since co-founding Regent in 2020, Billy has overseen growth of the company to over 40 employees, with a commercial backlog of Sea Glider orders worth more than $8 billion, and raised $50 million from world-class investors like Founders Fund, Mark Cuban, Peter Thiel, and Japan Airlines. Prior to Regent, Billy was an engineer and program manager at Aurora Flight Sciences, where he was responsible for developing new programs in vehicle design and technology maturation to support Aurora and Boeing's portfolio of future air mobility solutions. He also led technical program execution, financial management, and strategy for eVTOL aircraft programs, and worked as an air vehicle conceptual design engineer. Billy holds a BS and an MS in aerospace engineering from MIT. Billy, welcome to the Vertical Space.
Happy to be here, guys.
Our first question, is there anything that very few in the industry agree with you on?
Well, I think the hardest part of that question, maybe what the fewest agree with me on, is what is the industry? I think from you guys and a lot of the guests you've had, it's this sort of new aviation, new mobility industry. Maybe it's advanced air mobility, but there's an air in there. So I think my thought is that the industry is actually much larger than anyone thinks. The industry is transportation and mobility, which includes air and ground and maritime and everything in between, which is really what we're going to talk about today. And that the future of transportation that we're building right now is how to enable this multi-modal connectivity. So that the key is not just how good is my vehicle or how good is my system, but it's how effectively across cost and time and comfort and emissions and everything can I get a passenger from A to B.
Billy, what would you consider? That's a great response. So, and this will be a terrific conversation because, yes, this is a multimodal vehicle and capability you're building. But what's the most controversial thing you're doing?
I think we are making the stance that a maritime mode of transportation is a global transformational mode. And when people think about maritime transportation, the question we often get asked from investors, from partners and suppliers is, okay, you're building essentially a really fast boat. How is that transformational? Is there enough coastal movements today that this is going to change the way people travel? And our answer is overwhelmingly yes. 40% of the world's population lives in coastal communities. We've done studies of aviation and ferry routes and coastal rail and bus networks and found well over 1 billion people a year are moving along coasts or between coastal destinations over open water. So this is a massive market we're serving and a massive use case, and people sort of forget about it sometimes.
Billy, talk a little bit about the market. I mean, it's smaller than the overall advanced air mobility market, at least what people are saying it's going to be in the next 10 to 20 years, but it's still a sizable market. Can you give us a sense for how you view it?
Absolutely. So it sort of depends on what do you mean by market. And for Regent as the OEM, so we're selling sea gliders, providing aftermarket maintenance for sea gliders and training sea glider crew. Our market is in those revenue streams, but we define our serviceable market via the passenger movements. So from a passenger perspective, we're serving, again, that 40% of the world's population in coastal communities, or well over 1 billion passengers per year. But we break those passengers into passengers we can serve with existing battery technology at around 180 miles today with a sea glider today. That expands up to about 500 miles by the end of the decade. And then what we've done in building our TAM is we track each of those passengers. We know what their ticket cost is, whether they're on a ferry or an airplane or a train. We know what fractions of those tickets costs go to the ways that Regent makes money in terms of vehicle sales and aftermarket maintenance. And then we build back all of those parts that sort of go through the operators to the OEMs, regardless of the kind of mode they're moving on, and build that back up into our market. So in a very roundabout answer, Regent's market is about $11 billion today in coastal routes up to 180 miles and up to $25 billion into the future as battery technology expands and enables routes up to 500 miles.
Billy, what's the rationale for pioneering in the space of electric aviation, but at the same time limiting yourself to 40% of the potential market from the get-go?
Well, my background is aviation. My co-founder, Mike, and I were at MIT undergrad and grad in aerospace engineering. We've been aviation fanatics from the get-go. We're both pilots, started fixed wing. He went in a helicopter, I went in aerobatics. And then we ended up working at Boeing and Aurora Flight Sciences as aerospace engineers in the early days of this electrification of aviation market. So we're very passionate about aviation, and we saw that wide market opportunity, but we also became intimately familiar with the challenges, and we sort of got tired of hitting our heads against the wall on two major challenges. The first of which is the certification pathway. You look back through history, and even aircraft that look a lot like the past aircraft that have come out take sort of $1 billion in a decade. And now we're building them with new materials and we're gluing them together instead of riveting them, and we're flying them without pilots. All of that just raises the table stakes for what a certification pathway looks like. And on the other side, well, it's amazing that we can fly people on 100% battery electric systems. We can't get them very far. And when you take into account all the operational realities of flying aircraft, such as the batteries are aging over time, so I don't have the same range at the end of the year as I do at the beginning of the year. Those reserve fuels, so that if my airport is occupied, I can fly under powered flight to another airport and land safely. I might have a headwind. I might need to do a non-direct route because of noise mitigation. You take into account all these operational realities, and by our math, we could only get these vehicles about 50 miles with existing battery technology. And there exists vehicles that are going electric, that are very convenient and affordable, that are even going autonomous, that can do the 50-mile mission, and they're called cars. So, we were struggling with both how do we bring this new technology to market through certification pathways, and what is the real use case of this market once we get it there with the ability of the technology and the competing technologies. What we found is that we could solve those two problems. We could both get an expeditious certification pathway that makes no detrimental impact on our safety. We can still assure safety, but go through a different cert pathway via Coast Guard and maritime authorities, and that we can extend that range, very importantly, by getting some aerodynamic benefits and also reducing our reserve fuel requirements. We can double that range with existing battery technologies. So while, the global market of people traveling, we might only be able to access 40%, because of our range increases and our ability to get to market, we said there's absolutely a big enough market here, $25 billion plus, that this is a viable product.
So does the bull case for Regent include delays in certifying conventional electric takeoff and landing aircraft?
I think both conventional aircraft and sea gliders can and will work together. Aircraft can do things, admittedly, that sea gliders can't. They can service landlocked communities. They can do overland flights. Sea gliders can do things that aircraft can't. We're probably getting there first. We can go a whole lot further, and we can also do it less expensively with much wider accessibility of the supporting functions, of captaining the craft, of maintaining the craft. So sea gliders will always be easier and cheaper and longer range. Aircraft will always be able to service land. So I don't see them as competitive. It's really, are you betting on something that is sort of fundamentally easier to bring to market and easier to support, or something that may, in its fully recognized case, have a bigger market, but it's going to take a whole lot more to get there, and there's more risk to get there in the meantime. Mm-hmm. And I think they're complementary.
So imagine we're 5 years into the future, perhaps 10 years into the future. You guys are well on your way, and conventional regional electric aircraft have also been certified. Mm-hmm. So in that world, how does the value prop of sea gliders change if you have that conventional electric air mobility on a regional level? And how will people then choose to go the maritime routes versus leveraging point-to-point existing airports?
Yeah, so I might throw my colleagues a little bit under the bus here, but to answer this question, I'm going to start with rewinding 5 years and saying, asking how some of the aircraft competitors in the space would have answered this question 5 years ago, and they would have said, yeah, in 5 years we'll be in service, we'll be certified. This will be a part of the daily operations. This industry really started in that sort of 2016, 2017, 2018 timeframe. And all we've seen is delays in certification, decreases in range as these vehicles have come to market. And here we are, mid-2023, still very, very far away from these operations. So I think if we fast forward 5 years, Regent's in operation in many places around the world where our customers have already put firm deposits down and are ready for these vehicles, and we don't need any Herculean feats of physics to bring our vehicles to market. And maybe there's one or two other aircraft, one or two aircraft in market, but they're not necessarily proliferated, to the extent they're talking about. So I think 5 years, this is like, you can take sea gliders in these places because they exist and they have the range for it. And in these other much fewer places can you take an eVTOL or an electric aircraft. Fast forwarding 10 years, and now maybe some of the certification challenges in battery technology has advanced and been figured out, and now aircraft are a little more available. We'll be on to our larger system. So we're coming to market mid-decade with Viceroy, our 12-passenger vehicle. But by the end of the decade, we'll have Monarch, which is a 100 passenger vehicle. And now we're going to be supplementing and replacing regional aircraft and regional jets and turboprops and even small single aisle aircraft. On the ferry side, we're replacing and supplementing fast passenger ferries. So Regent's already going to be moving on to enabling our customers, the operators, to provide really mass transportation, really giving sort of the advantages and the customer experience of high-speed rail for a small fraction of the development cost, but that same sort of reliability and comfort and ease. Whereas I think in 10 years, we're going to see aircraft just start to really create the market head that they're talking about now and sort of have been talking about for the past 5 years.
So part of the reason that you're, if I could call you a darling right now, Regent is that you're able to provide a capability with a lot fewer of the hurdles that some of your peers may have.
Mm-hmm.
So your ability to get to market quickly with a smart aircraft that could be more easily certified and you can get to the market is a big part of your appeal. David Neilman, a recent add to your advisory board, said that there's an urgent need for fast and sustainable coastal transportation. Talk about that, because that says that there's a distinct need, in addition to your speed to market. There's a distinct need there. How does that different, or in addition to what you've already talked about, to the needs of the market?
Sure. Well, I'll make one clarification first, which is, you said we're an aircraft, and that's an important differentiation that, sea gliders are not aircraft and that they are sort of their own entity, a class of wing and ground craft that is really a hybrid of boats and planes, but it is neither specifically a boat nor an aircraft, even though it has wings and flies. But for David, while I can't, speak exactly on behalf of David, I can certainly parrot his stance that the urgent need for sustainable coastal transportation exists. I mean, that is obviously one that we share very deeply. And the reason for sustainable coastal transportation is that, localization of passenger movements, of just humanity in general along coastlines. People love the water. You think about where the major population centers in the world are, and they're along the water. You think about how humanity has developed and how transportation really started in the water, across water, which created our global network. And so that's why these big population centers are there. You think about why airports for the biggest cities are often coastally located for things like noise mitigation and traffic pattern deconfliction. The water is truly the connective tissue of the planet. We don't realize that as much anymore because airplanes can connect. But again, the airports are coastal. Roads can connect. But you think about routes like Boston to New York and LA to San Francisco. Those are some of the most traveled regional routes in the country, certainly, and there are many like them around the world. Those are both coastal because the population centers are coastal. So that is the urgent need for specifically coastal transportation, is that our population centers are coastal, people are moving coastal today. And in the regional mission, in this sort of 50 to 500 mile range, there's no good solution. You're waiting in the airport longer than you're in the airplane. You're stuck in traffic no matter when you leave. And so you're going to be in the car for multiple hours. Boats are too slow, and rail either, doesn't exist in terms of high-speed rail infrastructure, doesn't exist in the US, or if you can create that high-speed rail infrastructure, you're talking projects that are tens to hundreds of billions of dollars. So sea gliders are really filling that niche in that 50 to 500 mile regional transportation need use case on a coastal route, which happens to be a very needed use case.
Given the market appeal and the opportunity that you're describing, would you pursue that mission even if electric propulsion was not readily available?
It's absolutely an important mission to pursue. And the electrification is really an example of how a bunch of different needs and advances all came together at the same time. So again, my sort of view of the world and the needs and sort of new technologies that present a benefit to humanity was formed by my education and exposure and passion for aviation as an aerospace engineer, and then as an engineer and a program manager on electric aircraft programs and eVTOL programs. And so we saw the promise of this electric technology from the sustainability perspective, which is obviously existential and critical, but at the same time, non-urgent, as in everyone knows that the next generations of transportation, the next new mobility technologies need to be sustainable, but no customers will buy it only because it's sustainable. That's sort of table stakes. But there are benefits across the economics, a drastic reduction in maintenance costs, in fuel costs, the reduction in noise, the increase in reliability, and therefore safety. These were all the promises of electrification, but we're in an age right now where electrifying aircraft cannot get them very far. And so in our view, they didn't target the markets that were most painful for us. I grew up in the Boston area. That Boston and New York route is exceptionally painful. It is known as like the painful route. So we really want to service those use cases. We sort of dusted off this concept of the wing and ground vehicle and said, hey, if you could electrify this, if you could take all of these advantages and promises of electrification, apply it to a wing and ground craft, you could solve both the certification and the range challenges. And then it turned out that in order to unlock the wing and ground vehicle, we had to solve wave tolerance and maneuverability. That's where our hydrofoils come in. That's why sea gliders are different than wing and ground craft. They're the first wave tolerant and harbor maneuverable wing and ground craft in history, and that's because of the hydrofoil systems. And to enable the hydrofoils, the electric propulsion was the design case. So we sort of started from the electrification in terms of its economic benefit, its sustainability benefit. But then from an engineering perspective, the distributed propulsion and the use of electric propulsion actually unlocked the hydrofoils, which unlocked the operations, which unlocked the whole concept.
Billy, before we get into the details of Regent and what you're doing, and again, one of the reasons you're getting so much attention, you overcome many of the hurdles that others have in so many different ways. One is, for example, the landing spots. You don't have the same challenges, but you still have a dock, I assume, you have to launch from. So talk a little bit about the infrastructure, and then talk a little bit about quote unquote air traffic management. I mean, you're a sea glider, you're not an aircraft. And so you don't have, these are two of the big hurdles that eVTOLs are facing, is that, flying from city to city. So let's say we're leaving from Boston, and we're going down that difficult corridor, which I live on, down to New York. So explain how that will work, and what are the hurdles other has that you don't have, or what unique challenges do you have between Boston and New York, and how would it be deployed?
Awesome. Let's do that route because I'm very familiar with it. So, and we'll sort of do like the side by side, of taking your aircraft versus taking your sea glider. So from the city center, we'll drive down maybe to Seaport is where we'll have our sea glider dock. And it's pretty much a dock that exists. Very minor modifications to a dock needed to accommodate sea gliders. Charging infrastructure, we'll want to put that there. I'm actually unclear on the state of charge availability in Boston, but I can speak for Miami and I can speak for most of Europe, where their ports, whether they're ferry ports or cruise ship terminals, are already electrified because these places are moving towards electrification of the shore power. They don't want these ships running their just disgusting engines in port with horrible emissions. So they're electrifying the ports to the order of many dozens of megawatts to charge these massive cruise ships, and it'll allow sea gliders to tap off these lines in these places. But I'm not sure about Boston, so maybe we need to bring some charge down to the docks there. But we get to the port and we just hop on the thing. Maybe we walk through a metal detector, but it'll be a lot like boarding a ferry or boarding a train. We're also going to do our eVTOL, which if we have found a place in the middle of the city with that very expensive real estate, if we have cleared, this air traffic control such that we can move through the corridors over a crowded city, maybe we can hit the vertiport in the middle of the city. But if we're talking within the next 5 and maybe even 10 years, we're likely going to the airport for this takeoff. And we're talking about regional ranges anyway. We're talking about a Boston and New York trip. So I'm going to assume for this perspective that we're talking about a fixed wing, conventional takeoff and landing electric aircraft that can somehow do this range. So we go to the airport, go through security. If you don't have pre-check, taking my shoes off, have to walk through the whole airport, get there early. Maybe we're waiting on, the pilots because we have this really severe pilot shortage in the US. We have the 1,500-hour rule. It's already really crippling regional commercial air transportation today. So maybe there's some delays there. And then we hop on the plane, and it's a large plane, it's 200 to 300 seats. So we're going to wait for everyone to board the plane. Back on the sea glider, we're starting with Viceroy, the 12-passenger vehicle. So I hop on, there's 12 other passengers that get on. We board very quickly, and we're on our way. Now, the sea glider has 3 modes of transportation: float, foil, and fly. So as we leave the marina, we're floating. We have fantastic maneuverability in the marina. So we have 12 electric motors, 6 on each wing. They're very quiet, and we can drive them forwards and backwards. So we can turn on a dime, we can go forwards and reverse, we can move through the marina. Once we clear the marina and the no wake zones, we rise up on our hydrofoils. So we're directly en route. Meanwhile, once we're boarded on the aircraft, we're going to go out on the taxiway. We're going to work through Logan Airport. We're going to wait for our takeoff spot. Meanwhile, the sea glider's en route, foiling through the harbor. Now, hydrofoils, as an aviation guy, sort of historically, hydrofoils were like a mind-blowing technology to me, and we've started to see them proliferate with not only the America's Cup and Sail GP, but also things like e-foil surfboards. But they pick up the vehicle out of the water, right, on stilts. The foils stay submerged. They're essentially underwater wings. We're controlling them actively, by the way, so that the captains of these vessels, the captains of sea gliders, are only doing boat controls, left and right, fast and slow. But the user experience is almost that of driving a train. You're locked in on rails. The foils are controlling the vehicle in pitch and roll and ride height over the surface, even in waves up to 5 feet. Now we get en route. So we've made it to the edge of the harbor. The harbor traffic has died down. It's important to note that whenever sea gliders are in the harbor, we're only going as fast as other boats. We're going as slow as 20 miles an hour and as fast as 50 miles an hour. So we get to the edge of the harbor at 50 miles an hour. The captain presses the takeoff button. We gracefully exit the water, retract those hydrofoils, so they're like takeoff gear instead of landing gear. We settle into the ground effect about half a wingspan over the surface, so about 20 to 30 feet over the surface, and continue en route. As a passenger, I'm looking out the window. We're an unpressurized vehicle, and we're really reimagining the transportation experience to try to evoke more of a ferry or a high-speed rail experience and being cramped in an airplane. You know, we've taken a seaplane, we've taken a Cessna Caravan, and that is a tough user experience to be crammed like sardines into this little tube looking out a little window while this incredibly loud PT6 is rumbling and you're shaking with turbulence. In our case, we're at low altitudes in the boundary layer of the Earth's atmosphere, riding on that ground effect, looking through windows the size of car door windows at this incredible sight, just 20 to 30 feet over the water surface. So the airplane and the sea glider are moving down to New York together. I assume we're going to go to Manhattan because it seems like there's a lot of people and business going on there. So the sea glider is going to go into the East 23rd Street Seaplane Port. We've actually already spoken with the Economic Development Committee in New York about this. We've been talking with the Coast Guard about these operations. For the sea glider, we'll actually probably land in the Sound and we'll hydrofoil through the whole East River. And that's pretty important too, that we don't need to clear large runways for takeoff or landing like a seaplane or a flying boat would. We can put it down wherever, and then we can do that terminal distance, even if it's on the order of 12 miles throughout the entire East River as a boat would, again, on our hydrofoils. The airplane, meanwhile, is getting into the traffic pattern, which might again be delayed for one of the airports in the area, going through your standard, pattern, landing, taxi, going through the airport, dealing with that transportation. Meanwhile, the sea glider has now floated into downtown Manhattan. You get off and you're ready to go.
Who is controlling that sea glider? You don't envision any air traffic control, even though they're above the water.
That's correct. Although it's important to note, above the water, we are very close to the water surface. So an aircraft is staying a sea glider is staying within a wingspan of the water surface at all times. That's below the height of a sailboat mast. That is well below the height of a cruise ship or a ferry or a cargo ship. And so that is very much the maritime domain. There's no special cutouts today or special clearances necessarily for sailboats near airports. It's all part of existing transportation. So we are truly following that nap of Earth, within the wingspan of the surface, flying in the ground effect. And as such are totally in the maritime environment. So sea glider captains who will be maritime trained, they'll have their maritime master's certificate, and then they'll go through a sea glider type rating course, will be trained in maritime navigation, red right return, right of way rules, all that sort of stuff. And that is how it works today. And there are fast ferries today. There are hydrofoil ferries today, hovercraft today, and those faster ones are moving at speeds of 40-ish knots or so top speed, and they're able to maneuver in the harbor environment at those speeds. And that's really the place where we'll see the most traffic, which again will be on our hydrofoils at the same speed. Now we'll augment the captain's situational awareness with a full sensor suite, right? So we'll have forward-looking radar. We'll be plugging in with AIS, which is the maritime transponder system, very similar to ADS-B. We're investigating things like computer vision for above surface. We'll likely have sonars on the foils below the surface. We'll stitch all of these sensors together and fuse it into a picture that the captain can see. And then at the end of the day, the captain is also doing what maritime captains have always done, which is just looking out the window. And this isn't just a theory. We've actually done this. So we've taken helicopters and we've flown them 50 feet off the deck in speeds in excess of 100 knots in some very crowded environments. And we've seen firsthand with our own eyes, like there's the boat and we can see it and we have plenty of time, minutes to very lightly change course and still miss the boat by a mile. And we're also using these same helicopter platforms operating in this sea glider-like fashion to hone that sensor suite I was just talking about.
And so, Billy, has the Coast Guard given you, or any authority, given you clear guidance on the permissible routings for these routes or the speeds at which you are able to operate in different areas? Certainly, I'm familiar with the Northeast. As one example, will you be permitted to go down the Cape Cod Canal? And if so, at what speed? Or are you going to have to go all the way out around the Cape for these types of operations?
Sure. So we don't have specific guidance on routing, and this will be something that evolves as we get closer to operations. Not all vessels have prescribed, courses while they're underway, and some ferries do a little bit more. So we'll take it on a case by case basis there. From the Coast Guard's perspective, they are our regulatory authority. From the international perspective, that's the IMO, the International Maritime Organization. So we'll be working with them on all aspects of, vehicle construction, crew training and certification, and eventual operational authority as well.
Okay. And now down at, even at these very low altitudes at which you'll be operating, you will be in an area where drones may be operating, and drones may be in the future deployed in a variety of maritime and fisheries management type missions. Do you have a strategy for how you're going to deconflict with drones, or do you have any interfacing with the FAA that you're going to need to do around that question?
So we've been interfacing with the FAA since, the founding, when we had the FAA and the Coast Guard on a phone call, and we were talking about this international precedent for the various types of wing and ground craft and how the U.S. would handle it. And we've had similar conversations with other countries where our customers are. Regarding the drone issue, we've not specifically dug into that one. I would say that having that many drones at that low altitude is not only going to be a problem for sea gliders, it's going to be all vessels on the water. So solutions that are put in place for the true proliferation of low altitude maritime based drones is going to have to be something that works within the existing construct of maritime operations, and sea gliders will sort of fit into that picture.
It's interesting to consider whether you might equip with ADS-B, even though you're not an aircraft, as a way to deconflict. But I guess this is the flip side of the gray area, in between maritime regulations and aviation regulations that you're going to end up having to walk into.
For sure. And I think that's, part of the unique opportunity we have in terms of defining what that maritime situational awareness suite looks like. Vessels will have a moving map or something. Aircraft have the 6-pack plus, right? So what does that user interface, that human machine interface look like for a sea glider? We're actively developing that, and we're working with the Coast Guard, and we're working with DoD to say, what is the right information that is presented to the sea glider captain, and how can we give them, maximum situational awareness on the water and in the relevant altitudes.
What are ports or the Coast Guard or the relevant authorities most concerned about when they hear your pitch? What are the key risks that they flag?
I think to some extent, the first one, and this is sort of looking back, this is, before we achieved our approval in principle with Bureau Veritas, which is akin to the aviation cert basis. That was a big deal to get to that recognition of, these are the rules of the road. And if you build to this spec, we will classify your vessel of the sea glider and give it international class. But to get to that point, like when we are first sort of talking to the different classification societies, and classification societies are independent bodies, can sort of make decisions on what they support. There was certainly some apprehension, right? They hadn't seen a vehicle like this before. Maybe they had heard of an acronoplon or seen a wing and ground in the past. But I think to some extent, there's sort of bad associations with it, or that's just an achronoplan. That was some crazy thing they did in the 60s, or that's just some hobbyist working on a vehicle like this. Most of these societies had not seen a team and a technology come to them with the technical rigor that we have, coming to them with the aviation background, where we were expecting, a very meticulous and arduous certification process, and rightfully so, because we're going to be flying millions, hundreds of millions of people on these vehicles. And so we need to assure that safety. So the next step was sort of, okay, this, get over the hump on this is new. The next step is, okay, your thing has wings and it flies, and we do boats. And then we got in the details of, okay, well, what does that mean? And you talk about the structures, and the structures, or the structural analysis is still the same. We're still talking carbon composite structures and loading cases and failure cases. And to some extent, maritime actually leads in that space. Like, that's why we're building our vehicle with a combination of boat builders and airplane builders. But boat builders have been using composites for a lot longer than airplane builders have. So, okay, so they can analyze that, and we're looking at wings, but you look at, sails on boats today, you look at hydrofoils, like those are wings and lifting surfaces with the requisite level of, fluid analysis and structural analysis behind them. So we can sort of translate all of the technical aspects of the vehicle into a maritime body and say, a lot of this expertise already exists. And then from there, it's really a similar process to an aviation, where we're talking about, which systems and which components have the most risk, have, the most associated hazard with them as we go through our failure trees and things like that. And let's spend the most time on ensuring those systems are safe.
When your operation begins to scale, and now it's not just a couple of sea gliders, but there's ports full of them, and the intensity of the operations increases, what's the impact to existing port traffic, port infrastructure, port systems that you expect to receive some pushback on? And perhaps as an analog, we can look back to the ADS-B conversation with drones, and how air traffic control prohibited small drones from using ADS-B out in fear of saturating the spectrum, in fear of just multiplying the workload on air traffic controllers. What's the equivalent in your case?
Yeah, I think it'll be targeted at port infrastructure. Coastline is limited. And so as we think about where do sea gliders move, admittedly, at least the Viceroy Sea Glider has a pretty long beam, right, or wingspan. So, there's some special considerations in terms of how we move it around in a crowded harbor. I'm particularly interested, going back to Boston, and that Boston and Nantucket route. So Nantucket's a rather tight harbor. So, if you think about scaled operations of this, how are you going to move these sea gliders by each other in the waterways? So that's probably one of the first places where you'll experience growing pains, is those small harbor operations and limited coastline operations. I think from the operational perspective, there's a potential to even get better with scale, because the sea gliders are always, we have these sensor systems on them. They're all emitting on AIS. They're all sensing things. And there's this opportunity to share the data between them. So now we can actually build up this really fantastic, multi-sea glider informed picture of the maritime environment. So I think it'll be more on like near harbor operations and infrastructure. Just, we need to build more docks. We need to build more terminals to accommodate, larger passenger movements.
And when you were talking to the FAA initially, were they concerned about the flyaway failure mode, for lack of better words, of somehow a failure in the flight control system, and now all of a sudden you start interacting with the national airspace system?
It puts the onus on us and the maritime certification effort to ensure that these vehicles are restricted to flying within ground effect, right? So there is as much a risk from that perspective of flying up and entering that airspace system and a potential collision there or something, as there is flying down and impacting the water at a high speed. Like, you need to ensure that you don't do either. So that pertains to our certification pathways and our redundancies and robustness on the automatic flight control system to really lock in that altitude in all conditions.
So speaking of certification pathways, can you describe what the certification strategy is?
Yeah, so we'll be working under maritime authorities in the U.S. The Coast Guard wrote us a letter and copied the FAA to say that they'll be our certification authority. And so the first step with the Coast Guard is called the design basis agreement, which is, again, sort of the equivalent of the cert basis. In maritime, we work through more of a bespoke, like vessel by vessel construction, which is actually a pretty amazing concept compared to an aircraft. With an aircraft, you need to do your type certificate, your airworthiness certificate, and your production certificate all at the same time. You need to bite off all of that work and all of that risk at the same time. Now, of course, once you're done with that, you can just start cranking off airplanes off the line and you already hit it, but that costs a whole lot of money, which a lot of these companies are raising in venture to do, and takes a whole lot of expertise and time. The construct in maritime is more on a vessel by vessel basis. That's how maritime works in general. So, you create your approval in principle, which is on the class society side, on the international side, or a design basis agreement, which is with the Coast Guard on the US side. You follow that vessel, and they will actually have inspectors come and visit you and ensure that you are building the vessel to the specification. And then you approve the vessel, right? So on the Coast Guard, it's a certificate of inspection that they have inspected your vessel and that it met the design spec that you built it to. And then you enter service. So that's actually from a startup perspective, from a capital efficiency perspective, a much more capital efficient way of bringing your first vehicles, your low rate production vehicles, to market, because you can go onesie twosie. And what you do from there is now you start building up this concept of a type certificate. And this already exists in maritime today, but it's on the component side. So our strategy will be that we will, start with a motor, a battery, and we'll type certificate the motor or the battery in the maritime context. And then we'll combine them into a propulsion system. And now we'll have a type certificated propulsion system, which becomes a type certificated wing, which eventually becomes a type certificated sea glider. But in this way, we can sort of smear out that very admittedly, like that is a very involved, intensive process, very capital intensive process as well. But we can sort of smear that out over our production. We can still ensure every vessel, every sea glider that comes off the line is safe and built to spec, but it starts onesie twosie with inspectors actually coming to your facility and visiting, and it ends with that type certification after you've actually been in market already.
So even though the process seems different, I imagine that the safety thresholds when you have passengers on board must be the same, correct? The same expectation of safety. So do you end up having the same kinds of safety and design assurance type discussions that you would have with the FAA?
Absolutely. We're having those discussions and have had those discussions with both Bureau Veritas on the class society side and are having those discussions with the Coast Guard now as we move towards our design basis agreement. And it's the same sort of thing. We create our risk matrix and we identify what is a catastrophic event and a hazardous event and assign probabilities to those. And those probabilities scale to, what the occurrence rate of that specific failure is. So from, a catastrophic failure event, one where, you lose multiple lives, that can never happen probabilistically once in the entire life of the entire fleet of vessels that you make. And so you can work the math back from a utilization perspective to inform those probabilities. And now we have that same risk matrix, that aircraft are certifying to.
So given that similarity that you're just describing, what makes those discussions with maritime authorities easier? And if we just, maybe extend the analogy a little bit further, maybe this is overly sort of stretching the analogy, but if you had an electric or any other aircraft that's just flying at extremely low level, at 20 feet above the water, how is the safety discussion different in your case? Is it just the fact that you can dip down and land on the hull? Is that how you mitigate a lot of these things? Because at the end of the day, you're still flying at relatively high speed with persons on board.
Yeah. So from the safety analysis perspective, it is the same. You're worried about loss of flight control or propulsion. You're worried about, high speed impacts, which could be hazardous or catastrophic on the water. The fact that we are always over the water, the fact that our hull design is this deep V shape that sheds wave energy and can maintain high speed impact, and designed in a similar way to power cat boats that can already do speeds of 100 to 200 miles an hour on the water, literally jump off the surface, 10 feet in the air and come back down and keep on ripping. The fact that we're using that sort of a structural analysis and failure case gives us, as we're drawing our failure tree, sort of coverage for certain failure events, right? That if you impact the water at a certain speed in a certain orientation, you're okay. Now, from a probability perspective, you still have speeds and orientations that aren't okay. And so by this, probabilistic analysis and the way that we're certifying aircraft today, as well as sea gliders, you need to ensure that that gets below your risk threshold, right, or your probability threshold. But that is certainly, one way of saying, okay, like, we have another means of handling failures of this kind, because if you had these failures over land, that becomes a catastrophic event every time. And in our case, it's a catastrophic event only part of the time. But I think in general, sort of taking a step back and talking to the entire certification process, the aviation certification process is very prescriptive. I think the FAA was founded in 1958 or thereabouts. That is well into the jet age. Aircraft really haven't changed much since 1958. And so when you look at how the FAA certifies, they certify on a functional basis, but those functions are representative of a configuration. So you certify a fuel system and you certify an engine. And now I am an electric aircraft manufacturer. I'm going to the FAA saying I want to certify this aircraft. And they look at my batteries and they're like, well, is that an engine or is that fuel? And the answer is simultaneously yes and no. And it's that sort of, square peg in a round hole sort of concept. That is one of the reasons why this certification process has become so burdensome. From the maritime perspective, the same maritime authorities need to inspect and classify vessels that range from a passenger fast ferry to a hydrofoil ferry to a hovercraft to an oil tanker to an oil rig machine. All of them are passenger safety critical. We're sending people across the ocean. We have people living overnight in a vehicle that's drilling for explosive substances. So they're all safety critical, but they're all completely different. And to accommodate that and to still ensure human safety on these vessels, the maritime authorities have created a much less prescriptive system. It's really where the FAA wants to go, as they went from, Amendment 62 to Amendment 64. They want to make this more performance-based and risk-based, and they're taking one step at a time. But maritime was really founded in this. And so we start with the risk matrix, we start with the configuration, we start with the fault tree analysis, and then we dive down into those places that have, the least amount of maturity or the highest risk and highest, impact from a catastrophic failure perspective on the system. And that's the best way to really certify new technology.
Okay, Billy. So in the discussions with the maritime authorities to certify this aircraft, you're going to have that conversation. And are you going to, as part of your safety case, make the assertion that in the event of a failure, you will always be able to execute a graceful landing on the water? Because obviously, as pilots, we know that landing an aircraft on the water is a delicate maneuver, and it can be very unforgiving if it's not executed the right way. Is that part of the design and the safety cases? No matter what type of failure the aircraft may experience over the water, it's still going to be able to execute a graceful landing at the right speed, et cetera, as the mitigation to that risk.
So it all needs to be from the probabilistic perspective, right? In line with the risk matrix. So any aircraft today are essentially saying the same thing, but there's still the potential, there's still a probability that you lose all control or lose all power and have to put the aircraft down over land in some case. And the whole point of that certification process is that you can drive that risk below a certain probability, right? So ours is the same thing. And the way we will get there is to say the system is designed with high levels of redundancy to ensure that never happens. There's always a incredibly low probability chance that it does happen, and then a fraction of those cases are covered by our structures and being down over the water. But baseline, the system is absolutely designed with the redundancy from the sensor system to the flight control system to the flight software system to the propulsion system to always be able to execute that controlled landing. Now, importantly, a distinction between aircraft and sea gliders is that the captains of sea gliders are not in direct control of the vehicle. They're not commanding pitch and roll and even necessarily altitude directly. You drive a sea glider like you drive a boat. the operator inputs are left and right and fast and slow. And then you have your mode change buttons. And so you can mode up from float to foil. You can mode up again from foil to fly, and the vehicle will execute the takeoff, retract the foils, and settle in a ground effect. It'll coordinate turns. It'll control altitude. It'll reject gusts while it's flying in that ground effect, but it'll do so automatically. And then, you press the land button and it'll coordinate that landing itself. And that was important because your point about the safety of near earth or near water operations is absolutely well taken. It was one of our founding principles of seaplanes, and especially wing and ground craft, do not have the greatest safety record. But when we interviewed those pilots, they spoke to the incredibly high task load of flying a wing and ground craft. We found them. There's a handful all around the planet, but we found them and we interviewed them. And so we said, that's what we need to fix. And to do that, we're going to abstract away the dangerous aircraft parts of the operation. We're going to have systems that can actually handle that, do that with an envelope protection system, and our operators will just drive these things like boats.
I'm curious to learn, when you're interacting and talking to the maritime authorities who are used to seeing and certifying boats. And yes, there are all kinds of different boats, but ultimately they all share a very common, same sort of set of design choices. And then you come to them with an airplane. Do they find themselves out of their depth quickly? Do their eyes glaze over and say, well, we don't really know how to think about certifying an advanced fly-by-wire flight control system. We're not really sure how we're wedging an airplane into a maritime regulatory domain. How are these discussions coming along?
We haven't found that at all. I mean, I'll speak to, we are further along on the international level than we are on the domestic level. So I'll speak to our interactions with Bureau Veritas so far on the class society side, but they approached and said, we've classified all different kinds of systems. And I'd actually, I'd contradict a little bit that all boats are the same, because an oil rig is not at all, a boat. It has pylons, it has a drill, it has living quarters, and they need to ensure the safety of that. There are also flight control systems in effect on the water. So hydrofoil ferries, which exist, the Boeing 929 has a flight control system on it because it's up on its hydrofoils and it's going 40 to 50 knots. So as we draw these parallels and walk through, in this case with Bureau Veritas, the classification societies, we can draw these parallels and they have understood it. And I think, Bureau Veritas has certainly been very forward leaning and working through with us on our approval in principle and now into, the working levels of our classification.
And do these maritime authorities turn back to their aviation counterparts and say, what do you guys think about this particular challenge and risk mitigation in the air domain, or are they really two separate systems?
I think that's always a potential, and we'll be the first to admit, we're relatively early down this process. We've come up on the international side with a rule basis. There exists a rule basis for wing and ground put out by the IMO in agreement with ICAO, but under the ownership of the IMO for wing and ground internationally. And then with Bureau Veritas, we picked up that document as sort of the baseline. We're going to use the IMO WIG rule set. We're going to add all these other rules to it, these standards, in some cases pulling from aviation standards, like on propellers, for example. Like it made sense to pull from aviation standards. So we sort of put that together. And we can move forwards on that, but we have agreed to the rule set now. We're at the cert basis side. So, we're talking about entry to service mid-decade. We still have a ways to go in this. And it's absolutely, within the realm of the possible that the maritime regulator hires independent consultants on the aviation side, does something like the FAA does today in terms of hiring a DER or a DAR, some sort of, third party that has delegated authority, or even contacts, aviation authorities for help or advice or advisory or something like that. So we're working through that process with them.
Billy, who do you see operating the aircraft? Do you see conventional airlines? Do you see new organizations? Sorry, the Sea Glider.
Yes.
You were about to correct me. So who's going to operate it? And listen, you have billions in orders, and some of them are firm orders. Who are they? What's the common denominator of the operators?
So the common denominator of the operators is that they see this coastal and overwater market as a problem that needs to be solved, and they have operations there. So our customers are actually roughly split 50-50 between ferry operators like Brittany Ferries and FRS Ferries, some of the largest ferry operators in the world, and airlines. So we have orders from Mesa Airlines and Mokulele and Southern Airways Express. We have strategic investment from Hawaiian Airlines and Japan Airlines. So, Hawaii, Japan, obviously some fantastic, maritime island hopping routes there. But even from some of our U.S. mainland operators looking at routes like Miami, looking at routes like Manhattan to the Hamptons, Boston to Nantucket, L.A. to San Diego or San Francisco, the Pacific Northwest, moving into the ferry markets in the Mediterranean and in Italy and Greece across the English Channel. So, we're seeing all of these markets, and sort of the cool thing is a route exists. It often happens that on these sorts of routes, there are both aircraft and ferries that service it, and so both become interested in our technology. So it's actually been really interesting to sell to these two very disparate operating customers, these two very different verticals from the get-go, sort of learn the language of each, learn the operating economics of each. Each one brings something to the table in terms of familiarity to sea gliders that the other doesn't, but also in terms of what the bar is, what that hurdle to bring sea gliders to services, and both have them because sea gliders are a new mode of transportation. Ferry operators are very familiar with the maritime environment, with the berthing, with how you work in the harbors and the docks. They're less familiar with the speeds. They're less familiar with, are you going to be able to have the situational awareness? They're the ones that are driving at those questions. They're the ones that made us get in the helicopter and figure out ourselves, like, is this actually real? Can we do this? On the aviation side, they're very familiar with this sort of network model, scaled operations, moving vehicles around because they're so fast and they can do longer range. And so obviously, the hurdle for the airlines is, well, how do these interface with our existing air networks? Are we going to combine them with coastal airports? Or are we going to operate bespoke sea glider line entities that are working from docks? And if so, how do we, train crew and handle luggage and things like that?
What's the cost of the sea glider? And what's the cost of operation vis-a-vis alternative? You talked about the Boston to New York route. I mean, that's an expensive flight. It's an expensive rail trip.
Yeah, so the really important factor for our customers who are the operators who are doing, largely commercial operations, I'll speak about it in a cost per available seat mile, which is interesting and also, industry specific in and of itself, because the ferry industry doesn't actually have a set standard of what is their figure of merit. The ferry industry is very sort of route specific, regional specific. This vessel does these sort of operating economics on this route. Maybe I have a per passenger per route metric, but they don't have an integrated metric like the airline industry does in CASM, and cost per available seat mile. But from a CASM perspective, and this is really where electrification comes in, you think about how aircraft age, and they age by the cycle. So they impact the landing gear, they heat up and cool down their engines, they expand and contract their fuselages with pressurization, depressurization events. Every time you take off and land, you do a cycle, and those cycles lead to your maintenance events, and therefore your maintenance costs and your overhaul time and all of that sort of stuff. As you shrink the route length, you can jam more cycles in a day. So you're just aging out these aircraft faster and faster and faster. And often your revenues and your margins are going down on these shorter routes because the passengers aren't paying as much for them. So suffice it to say, the economics of short haul are not great for conventional aircraft. What you really want is an unpressurized all-electric vehicle that truly ages by the hour instead of by the cycle. So when you think about it, aircraft can get, say, 20 to 30 cents per available seat mile if they're doing long haul, but you take those same planes, a turboprop, a large regional jet, even a small narrow body like a 737, if you make them do, we'll use in this case, repeated 100-mile missions, and you drive them every day on these repeated missions for 8 to 10 hours, they're about in the mid 40 cents. If you look at smaller vehicles that would even maybe do coastal routes like a Grand Caravan on floats or a Twin Otter on floats, those are upwards of 60 cents a seat mile. So our Viceroy 12-passenger vehicle can do it for 40 cents a seat mile. It can provide the same economics as a long-haul aircraft, really where these, where a small narrow body or large regional jet are meant to operate, actually a little bit cheaper. They can do 40 cents a seat mile, which is a 40% cost savings over these other small aircraft doing these repeated 100-mile missions, which are all well in excess of 60 cents a seat mile. Then as we scale, and I said, Viceroy is our first vehicle, mid-decade, 12 passengers. Monarch is our 100-passenger vehicle. That's the end-of-decade vehicle. That halves the cost per available seat mile again. So now we're talking 20 cents a seat mile. That's half the operating cost of, an ATR 42 or 72 or a CRJ 900 or a 737, A320, any of those vehicles. So we're talking about being able to have the operating costs for our operators who are operating aircraft today. And that is a transformational savings. And that's one that can either be maintained by the Sea Glider line, right, or the airline, but the Sea Glider line. In terms of margin, it's savings that can be passed on to the passenger with cheaper tickets. They'd likely split the difference, but importantly, it's upside for everyone. And you capture that savings largely because of the reduced maintenance cost.
And looking at the operating costs and comparing that to conventional aircraft, you're operating in a maritime saltwater environment. And what do you have to do to overcome the hurdles associated with that? How do you mitigate the saltwater factor and keep your operating costs on that aircraft down?
Yeah, so it's a great point. Thinking about it from the seaplane perspective, like why are seaplanes so expensive? You're taking small aircraft, which are already fairly expensive, and you're putting them in that saltwater environment. You're running salt water through a jet engine and putting it in a combustor, and you're corroding all the pieces. You end up doubling to tripling the maintenance cost of like a normal land-based caravan versus a caravan on floats. So it is a significant problem there. Our Sea Gliders are designed from the get-go to operate in that saltwater environment. So, all of the structures are carbon composite. The motors are sealed bearings. The components inside are meant to operate in that environment. We are designing with either, corrosion preventiveness or sacrificial corrosion areas that we know will corrode in mind. And that's why we have so many boat builders on the team, and naval architects are the team. They're used to designing vessels that live and function in the saltwater environment.
What do you estimate the annual unit demand for your Sea Gliders to be, and how does that compare to the Grand Caravans, for instance?
Yeah, it's, I think it's sort of similar to the use case of a caravan in terms of the size. We can actually carry 1,000 pounds more of cargo than a caravan can, at least within our 180-mile range. From Regent's perspective, getting into the sort of high double digits to low triple digit production per year on the 12-seat Viceroy, and then ramping up Monarch to sort of a similar level is what we envision. And our 8 billion in orders are sort of indicative that is the case.
Understood.
So you're in Rhode Island, so you don't see a whole lot of aircraft companies, or I should say, I'm going to use the word aircraft. You're not seeing a lot of aviation organizations coming out of Rhode Island. I have to guess the maritime connection is a nice one. So, why Rhode Island, and how is it finding the kind of talent you need in an area where you don't usually see aerospace, although you see a lot of maritime talent?
Yeah, well, I'd be remiss if I didn't mention, the aviation roots of Rhode Island, and that some of the first aircraft and flying boats, the Gallaudet aircraft was invented here, and the designs were sold to PBY and sort of eventually manifested into the Catalina. So we have those aviation flying boat roots in our blood, so to speak. But no, it's a fair point. So we were founded in the Boston area. Had a lot of sort of MIT influence in the founding team. We looked over the entire country, we're like, it's not clear that this is the best place to found. So where should we put Regent for, maximum probability of success down the road? The primary driver was the waterways. We had to be able to test our vehicles on waterways. So we wanted both sheltered inner harbors where we could test with lower waves and wind in the early stages, but then we also wanted ocean access so we could bring the Sea Gliders out and really put them through our paces. So that narrowed it quite a bit. Then we wanted, sort of a city nearby with an airport with at least decent connectivity. We couldn't be in the middle of nowhere, so that narrowed it a little bit. Basically, actually ended up narrowing us down to Boston area, Rhode Island, and Tampa Bay. So then it became a topic of talent. And, we did our talent studies. And it turned out that even inclusive of the Space Coast, when we drew our rings, we found talent. So the talent we have in Rhode Island, very specifically, is that naval architecture, maritime composites, best in the world boat building talent from the racing yachts here. And then very nearby, we have academia and some industry in the Boston area from the schools there. That's where we're getting a lot of software and flight controls. And then we also have big aerospace, not too far away in Connecticut, right, between, Pratt and Sikorsky. And so actually within larger New England, it was a great place to base because we have maritime where we are, we're surrounded by aviation. And it turns out for any radius we drew, more of the key people that we needed compared to Florida. So then it became Boston versus Rhode Island. And then it really came down to incentive packages and real estate. Rhode Island lured us with an incentive package worth up to $30 million here, which is pretty exciting. And then potentially even more so exciting is the space we have here, that we're in this Quonset Park. We're near Electric Boat, which does the nuclear submarines, and has built a sprawling campus. And we have the roadmap to the exact sort of campus here, all within 5 minutes of the water, all within, industrial zoned infrastructure. We have 30,000 feet right now. We're planning on opening 200,000 feet for Viceroy manufacturing by 2025, and an additional 400,000 square feet of manufacturing for Monarch prototyping and manufacturing and parts distribution and maintenance by 2027. So we have this fantastic roadmap here. We never need to move again. We said we were going to move the team once, and then this is going to be our home for the next decade plus. And we found all that here.
Billy, what's the rationale for being an OEM as opposed to an operator as well? I mean, the argument of being a pioneer in this use case, having a first-hand experience in operations and see how the customer actually uses and interacts with the product would be very beneficial in informing the successive design iterations and perhaps even greater value capture.
The answer is absolutely ruthless prioritization. We are inventing a new mode of transportation. So there's a lot of education that has to be done there. We are designing it, manufacturing it, certifying it to be safe, and then also working through, how we train crew and do aftermarket maintenance. So from that technical aspect, we have an enormous amount to do. And we made the decision very early on that we're going to focus on what we're good at, which is designing the aerodynamics and hydrodynamics and flight controls and flight software of the Sea Glider system. We're going to go horizontal across, sourcing the parts. We're going to buy motors and batteries and flight computers and actuators, even aerostructures from companies who are focused on that. And then so too, it made sense to partner on the operational side to leverage the networks, the passenger relationships, and even, the ticket booking systems of our operators, of the airlines and the ferry companies who are in existence today. That's how we felt it was best to bootstrap a new mode of transportation, other than trying to do the entire thing and take on the world ourselves.
What's the biggest risk in your business plan that you're still needing to retire?
At this point, the phase we're in right now, so we've already retired the technical risk. We know Sea Gliders will work. We've flown them. We've done all of our transitions. You think about eVTOL, and the hard part is in that hover to fly transition, which some companies have done, but some haven't yet. In our case, we wanted to retire the technical risk of the foil to fly transition, which was the technical hard part, as early in the process as possible. So we've done that. We've also, written software that controls the vehicle at that low altitude flight and ground effect. Currently, our major risk is execution risk. We're building our full-scale prototype. We plan on flying humans on board that full-scale 15,000 pound system by the end of next year. So this is really just, can we get our parts and execute and ensure safety for the human crew of that prototype Sea Glider vessel on the time frame we're thinking of. And then the next step for us is bringing it to market, where it becomes a manufacturing risk. It is another whole process again to spool up that low rate manufacture, and of course the certification risk. And we have to acknowledge that, while Coast Guard has, and Bureau Veritas and maritime authorities around the world have certainly certificated many different vessels of many different types. The Sea Glider is a new thing, so we absolutely admit that there is risk in that certification process, as is there risk in eVTOL certification processes, right? None of this stuff has been done before.
And so, Billy, with this path of going with a wing and ground effect craft and working with the Coast Guard, and as you say, avoiding having to do the full set of certifications up front, type certification, airworthiness, production, all of that. What do you say to the counter argument where there are people that have the mindset that says, look, I want to run towards the regulations because having clear regulations laid out for what I need to do effectively puts thousands of people behind me, helping me make the craft and operation safe. And what do you say to that counter argument that might actually in the long run be a faster and lower risk path for the company?
I think the more you front load with work, period, the more risky a venture. I mean, most of the companies in the space outside of, say, Eve are venture backed. And so there is an incredible time value of money there. All of these things take time and therefore money. And so the art of bringing new technology to market is to always bite off the lowest hanging fruit, because you can always raise more money at higher valuations in the future. And so you're like, how can I de-risk the key things now? And for us, how can we ensure safety of this vessel when we bring it to market? And we can do that by focusing on the technology and focusing on how do we bring the first one to market and then the first two to market and ensure that safety with the capital that we have. And then how can we prove from that success case, and investors love success cases and milestones. So once we hit that milestone and we show revenue, how can we then bite off the next more expensive apple of showing that we can do it repeatably on some process?
Billy, do you have the capital you need for the next couple of years to be able to execute your plan?
We're closing our fundraising round very soon, so we're imminently at that point. Absolutely, very confident we'll be able to get through the next few years and human flight of the Sea Glider.
You've started a new business. You've learned a lot since the beginning, and you have a bunch of entrepreneurs on the line. Give them some of the lessons learned from starting your business that you think would help them in their ventures.
Awesome. I'll share a few here. The first is you really got to want this. If you're founding something new and it has the ability to be transformational, you are going to have naysayers. You're going to have hundreds of investors turn you down. You're going to have people that don't understand it. If it was something that was easy or something that everyone got, it would have already been done, because there are a lot of smart people that have lived and existed and tried to do hard things before you. So you sort of need to ask yourself, like, why is it you that's going to do this? Why is this idea so special? And are you 100% confident that you'll execute on it, or you're at least going to give your all to execute? And you need to maintain that drive in the face of constant naysaying and constant rejection and constant doubt, because in general, the world is opposed to change. Like on the surface, people are like, yeah, new stuff. But when it comes down to the details of it, like change is hard. It requires new training and new infrastructure and new switching costs and new processes and all this hard stuff that, companies that are driven by bottom line don't want to do. So I think you just need to understand that as a founder, like this is a long, hard road, and you have to really believe, but that is sort of the validation and reward at the other end as you start to see, people in the public get over some of these obstacles, as you de-risk some of these, early concerns of the naysayers along your plan. Then it is so incredibly rewarding when other people start to, repeat your messaging and say, yes, that can be solved. And look at how your company did these few things. It's a long road. And I'll be the first to admit that Regent hasn't really done anything yet. We haven't made a Sea Glider. We haven't flown people in it. We have proved a lot along the way. We've proven that a Sea Glider is possible and that float, foil, fly operations are possible. We've proven that there's a massive market for it, at least interest, if we can build what we say we will in both commercial and defense. But to me, we haven't really achieved our objective until we deliver Sea Gliders to our customers and there are passengers flying around Sea Gliders and cargo being moved all over the world.
At scale. I mean, given that clearly this is a dramatic change in how people are moved between cities. So and my guess is most of your prospective investors get it. It's a really easy concept to understand. What's the most typical reason a prospective investor would walk away from the investment?
I'll give you two. The first one was I think the very first question we talked about today. Like, okay, so you're constrained to waterways. You're constrained to 40% of the world's population. Is that really transformational? Is the market big enough to generate venture returns? Because at the early stages, that's how the VCs think about it. You need to generate 100x class returns because they're expecting they need their portfolio of 10 companies to 10x, and they expect 9 of them to die. So you're going to 100x and return the whole fund. That's the basic back of the envelope math they're doing. So we've absolutely heard some investors turn us down to say, we just don't see the market as being big enough for venture returns. Whereas the ones who have backed us have said, yes, we see this as a transformational market and we get it. I think the other one is sort of just the general fear that it doesn't work. And it's sort of funny because when I press investors who turn us down, and believe me, many have turned us down, and I always press. I'm like, why specifically? I'm an engineer. I need that I need that delineation, that certainty. So what? Well, okay, you said technical, but what technical part are you concerned about? And they often can't say. And eventually, in the early stages, it was like, well, we want to see a sea glider work, and then we built a sea glider and it worked, and then we want to see people on board the full scale thing, and we're going to hit that milestone. And they'll probably say, well, we want to see it in operation. We want to see it certified. So I think there's always that next stage of risk reduction. Mike, our co-founder, sort of commented that even pertaining to our prototype itself, some of the feedback was, well, we don't think it can fly. We want to see it fly. And then we flew it and well, that landing looked a little tough. And we're like, yeah, that's all part of the evolution here. That's developing new technology. So that's, I think, the other reason when we're doing something that's so new, it's not another electric aircraft. It's not this very known thing, and I'm going to change one part of it. I'm going to electrify the engine, so to speak. And that is my, transformational new technology. We are doing, the operations are new. The way this interfaces with existing transportation systems is new. Of course, the vehicle is new. Even to some extent, the cert pathway is new. Because of all that newness, there is inherent, at least a perceived risk from some of these investors. And so there's always this, well, let's see the next thing. But I think, we have found some fantastic backers to date, and we've been, incredibly, humbled and fortunate to have investors like Peter Thiel and Mark Cuban and Founders Funds, our strategic investors like Lockheed and Japan Airlines and Hawaiian Airlines and Yamato, who's doing, logistics in Japan. We've built up a really fantastic group of backers who believed us early on.
Have you approached shuttle airlines? Have you approached a Delta, for example, where they own so much of this Northeast route? And what has been their comment about this offering?
We're certainly, I would say we're in conversations with all of the major airlines. Some airlines see, so backing up, there's sort of 3 models where sea gliders can work for an airline. The first is sort of the, your null hypothesis. It's like we're going to replace aircraft with sea gliders, right? So that's like an inter-island in Hawaii. You can actually replace the caravans and Saabs that Mokulele is flying today with sea gliders. The next one is sort of the eVTOL mission. It's your hub feeder. But instead of, a 50-mile radius around land, now we have a 180-mile radius along the coastline. And so that's working with the airlines to say, this is how we feed into your coastal airport. Look at all your airports. It turns out most of them are coastal. You may have not even realized that. This is how we're going to connect. This is what the passenger experience looks like as they clear airport security and have their baggage transferred from aircraft to sea glider. And then there's this really interesting third one that most don't recognize, which is a bandwidth alleviator. So you think about these large airlines like a Delta, and they're running large aircraft between hubs, but a large aircraft with high margin on tickets that can take many passengers occupies the same runway space and the same runway slot as a small puddle jumper. And in many airports, at least in the US, the constraint on making more revenue there is not a passenger perspective. It's just a slot constrained perspective. Right. So we go in and say, look, for example, in Miami, we can offload this regional traffic. We can offload, these tens of millions of people who are doing routes to Key West and the Bahamas and up and down the coast of Florida. We can offload them to a regional sea glider network, free up those slots for more large hub connecting aircraft. You can still connect them into your core network, and now you have the revenue opportunity of the seats. And we've done the math on that, and it's order about $500 million to $1 billion a year in some of the large coastal airports in the US, just freeing up these slots.
You spent some time with Jeff Bezos when you were an intern at, I think, Blue Origin. How has it changed your leadership style?
Jeff is definitely one of my heroes. And I found it amazing that, for a guy who's running Amazon, this global giant, he comes to Blue Origin and has lunch with the interns, like fully attentive lunch. And he's asking us, our names and what we do. And then he comes back to us later in the conversation and he remembers that. Like that was amazing, the level of attentiveness that a guy like Jeff could have at an intern lunch. And then at the end of the year, he sat front and center and watched all of the intern presentations. It took hours. And then he would dedicate his time for interns, the lowest level of an organization, to have that level of attentiveness, because he knew the importance and he knew that we were the future of his company, or that if he gave us this attention, that A, we could have good ideas that would positively affect his company, or B, we'll go out into the world, but we'll at least have good things to say about Blue Origin and him. That spoke to me from just his priority perspective, that of all the things that Jeff could be spending his time on, from Amazon to Blue to anything, he decided to set aside a few hours to sit front and center and grill interns. And grill he did. Like that was also when I realized, his brilliance too, was like, I had been spending, I've been living and breathing when I was at Blue, transparency, so windows for the spacecraft, and like I got so deep into the weeds on windows,
right?
And he came front and center and he knew every detail about the windows, and he had like read my charts and like he knew everything about it. I was like, this is an amazing level of attention to detail, and just spoke to me as a need. When you're scaling massive things and trying to take on world-changing technologies, you still need that presence and that attention to detail, and you always need to be thinking about what's next in that next generation. We actually just started our internship program. One of our interns is in the room with me here, which is awesome. And it just spoke to me in terms of that importance.
You earlier mentioned, when Luca asked you about how you were different from some publicly traded VTOL companies today, you said, well, let's see if they actually make the plans they're going to have in the next 5 years. If you were going to bet on one of them, which one would you bet on?
Oh, man.
Which one are you most, which one do you believe is most likely to achieve what it hopes to achieve in the next 5 years?
Yeah, I have two answers here. From a personnel perspective, and I know you just had him on the show before, Brian Yetko is my former boss. I think he's absolutely brilliant and incredibly capable. So I think Wisk found an amazing leader in him. And I think, what he sets his mind to, he can do. And I know they have an awesome team over there, because I used to be in Boeing Aurora working with that team. So only great things to say about that team. From an operational perspective, I think Volocopter to some extent has chosen the most constrained use case. They're not going to transition. They're going to do short hops. They're focused on just being very affordable, and maybe similar to my methodology here, like biting off the lowest hanging fruit and showing, what can we do first? And we're not going to have to go through this very aerodynamically and controls complex transition. So I think Volocopter is probably on pace for achieving their goals.
With all the work you've done, again, with the entrepreneurs of the line, what would you challenge them on? What's needed today that you think that they should be inventing or bringing to market, or further selling what they already have, based on what you see in the need of the sea glider or the advanced air mobility markets?
Sea gliders rely on batteries for sure. So, we've seen a lot of development in battery technologies. I think the interesting thing about batteries from the level we interface with the batteries is, we don't buy cells, we buy integrated packs. And so there is all of the opportunity in cell chemistries and energy density of the cell and manufacturing of the cell. But then there is also all the technology in the pack, because you need to contain thermal runaway, and you need to control heat, and you need to vent gases and all of these things. And that is a technology system in itself, especially when you consider that the next generation of cells, like the lithium metal cells, are going to be expanding and contracting, and you're going to have to, keep them under pressure as they're discharging, and all these different considerations. So the packaging is almost, I would say, as important as the cell to some extent. So it's been really exciting to see, our battery vendor for the full scale prototype is EP Systems. And we've seen, other battery manufacturers in the space really pioneering in that space. I think that's only growing as electric aviation as a whole grows. And then I would say the other one is just from the sensor perspective. Those sensors, as we've talked about here, and maneuvering and navigating on both the maritime environment and also as aircraft are proliferating in the skies, developing these sensor technologies, these detect and avoidance systems, eventually going towards autonomy. And there's absolutely a use case for autonomy in sea gliders, actually probably a more accessible one. You talk about low-hanging fruit. I would much rather design and build an autonomy system for a 2D environment with large, slow-moving targets rather than a 3D environment with very small, fast-moving targets. Definitely take maritime over aviation. So I think that whole sensor system, autonomy, detect and avoid, as we've also seen some companies start to pioneer in the space in both the aviation and the maritime sides, is going to be one of the other sort of supporting industries.
Billy, is there anything we haven't asked you that we should ask you as it relates to maritime sea gliders, or as it relates to the company? Is there any other message you want to send to our audience?
I think two things. One is to keep an open mind. And when you hear about how sea gliders operate, and if you're sort of initially filled with skepticism, I would challenge you to challenge your assumptions. The way people move today is not necessarily the way they move in the future. The way companies have tried to tackle these new transportation issues is not necessarily the right answer. None of them have made it to market yet. And so, challenge your assumptions and sort of explore what if when you hear about a sea glider. And then the other is that Regent is hiring and growing, and we are rapidly moving towards full-scale flight of a human on a sea glider by the end of next year and entry to service by mid-decade. So we've built an awesome team here, a world-class team here, and we'd love to have more. So hope we get some people out of this as well.
That's great. Very exciting. Thank you, Billy. Luca, anything else from you?
I'm good. Thank you, Billy. Thanks a lot for your time and for sharing your thoughts and insights. Really enjoyed the conversation.
Jim, Luca, thank you so much, and it was awesome to be on.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and/or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.